company called Acceleware is working on underground technology in the oil sands using radio frequencies. The idea here is to potentially revolutionize the process of extracting oil by so-called steam-assisted gravity drainage. It has been attracting interest from some big names in the industry. Geoff Clark is CEO of Acceleware. Geoff, thanks very much for joining us. One of the ideas here is to take oil, sticky bitumen type oil under the surface and make it liquid using heat from radio frequencies.
That's right. Thanks for having me. Essentially, that's the way it works. Not unlike a microwave oven, for example. We use radio frequency energy that we direct into the formation in situ, so underground. It seeks out water that's present in every reservoir, heats that water, and the heated water and steam then soften the bitumen or heavy oil so that it can be produced in a producer well.
It sounds like a microwave, because they work on the same principle, don't they? They seek out water in the things they're heating.
That's correct. Anything that's lossy to a radio frequency energy can be heated using radio frequency heating.
Now, the oil sands use vast amounts of natural gas to heat up this stuff. The idea here would be replacing some of that.
Yeah, that's exactly the idea, is that instead of having this massive steam generation facility that you use natural gas to heat the water to steam state, get it to your well sites, pump it underground, then you produce the oil plus a lot of condensed steam. You have to reclaim that water, you have to add makeup water to it, you have to filter it, clean it, recover heat from it if you can, and then pump it underground. We replace all of that infrastructure with a simple self-contained pad base, so you can keep it right on your oil lease. And you can reduce your CapEx investment by, we think, up to 50%.
What about the energy consumption by the system, though? Is it lower?
Yeah, we expect energy consumption to be about 40% less, including all of the costs associated with pumping that water around and producing the steam. We eliminate all that. We concentrate the energy right at the spot that you need it to be applied. And yeah, we think that we can reduce operating costs for producers by 40% as well. So it's kind of a win-win, because not only do you get that CapEx and OpEx benefit, but all of the ESG benefits associated with reduced carbon emissions, reduced water use, reduced land use. So there's a lot of benefits here for producers.
Now, you're working on a pilot project. Can you give us an idea of how much that'll cost? And can you tell us about any of your backers?
For sure. We're working on, in fact, right now I'm in the city of Lloydminster, Alberta, which is right near our pilot location at Marwayne, Alberta. And we're conducting a pilot. It's going to cost us about $25 to $26 million. We have about $15 million of investment from both federal and provincial government, about $5.5 million from SDTC, which is a federal government agency, $10 million from the Emissions Reduction Alberta and Alberta Innovates. And then we have about $6 million of funding from 3 different oil sands producers.
Now, this is not entirely new, this idea. I think it was about a decade ago, Suncor and other companies tried this. What are you doing that's different? What happened previously?
That's a really good question. In fact, the first time this was ever applied was in 1948.
Whoa.
In fact, so many years ago. And essentially, previous attempts at this technology have used equipment that was designed essentially for communications. So like that makes sense because it's radio frequency. You can use a high-powered TV or a radio source, use an antenna derived from communications, and deploy it downhole. Well, those things aren't really designed for downhole deployments. So we thought about this in a much different way, and we didn't use a communications-derived antenna.
Okay.
We use a different frequency range, and we think we have the secret sauce, so to speak.